Hello, Merry Christmas and welcome to my session for this year's Festive Tech Calendar. My name's Sam, I'm a Cloud Solution Architect with Microsoft, and today we're going to be talking a bit about Azure Container App Serverless GPUs. So what do I mean by serverless GPUs? Well, Azure Container Apps has been around for a while now and has offered a consumption model for running containers, which was mainly focused on CPU and memory use. However, we now have a new consumption option that also brings in GPUs. So you can create a container with a GPU on demand without having to deploy any infrastructure yourself and only pay for the usage of that container based on per second. So you can very quickly deploy GPU-enabled containers for your ML and AI workloads and only pay for what you're actually using down to the second. And with GPU resources being expensive, this can be a much more cost-efficient way to use those if you're only going to be using them for short periods of time, or if you need to use them on demand through scaling options like CADA or even batch processing. So in today's session, we're going to have a look at how this works, how you can get work going with it, and some of the scenarios that it can support. So first off, let's take a quick look at the benefits of using GPUs with ACA. So the first thing is we have near instant scaling. So we can deploy a new container with a GPU or scale up an existing deployment to run more GPUs very, very quickly. We can also scale down to zero. So we're only actually paying for those containers when they're actually in use. And we can use tools like CADA and so on to scale up and down based on our actual workload. So it doesn't have to be based just on HTTP requests or CPU usage, but we can base that scaling on things like service bus queue size, or files in a storage account, or things like that. And we'll see an example of that in the demos we look at later. Next, we are paying for that GPU only for the time that those containers are running. So when we scale to zero, we're not paying for anything. When we scale up, we start paying, and then we scale back down again, and we stop paying. This allows us to only pay for what we're using, and to be very dynamic about when we're being charged. Using ACA for AI workloads means you can run custom models that you create yourself, but you also have the option of running some Foundry models in ACA as well. And we'll see a bit more detail about that later, but that means you can deploy workloads that have come from Microsoft's AI Foundry directly into a container running in ACA and make use of that. Finally, because we're running in Azure on ACA, you get all the governance features of Azure. You can ensure that your workloads are running in the region that you specified. You can apply Azure policy and other governance tools around your workloads to ensure that you're compliant and following regulatory requirements and so on. So when you're using GPUs in ACA, there are two options you can use. So there isn't the full range of GPUs you perhaps see in the N series VMs. You've got two choices effectively. You can use the NVIDIA T4 GPU or the NVIDIA A100. And they both have different configurations and different use cases. So the NVIDIA T4 is perhaps the more economical option, which is great for small models, smaller than about 10 gig in size. And it can be very cost efficient for what it's doing. It's great for sort of standard AI applications that don't need a huge model. It comes with 16 gig of VRAM. Whereas the NVIDIA A100 is the much larger, but also much more expensive option that comes with a 80 gig of GPU memory and is great for large models, and it's also particularly great for model training. So the T4 is perhaps more suited to your model execution workloads, whereas if you've got to train models with lots of data, then the A100 is a much better suited scenario for that. Complex models with vision and scientific simulations and so on. And when it comes to actually deploying these into ACA, you combine that with the existing configuration you already know from ACA, where we can define how much memory and CPU our container gets. And we can tweak our container resource requirements to match exactly what we need and make those containers as big or as small as we want. When it comes to pricing, we're paying per second for these on the consumption tier, and the billing is similar to what you've already seen with ACA in terms of memory and CPU. So you're paying for the amount of vCPU seconds, so that's the number of cores per second, and you're paying for the amount of memory per second as well in gigabytes. But in addition to that, then you are also going to pay for the GPU seconds. So that's a fixed amount per second for each of the two different types of GPUs. And that will be added together with the CPU and memory costs to give you the total cost per second multiplied by the time the container is running. I mentioned earlier that you can run models that come from Azure Foundry. So there are a few models that are already configured to run with ACA and can be easily deployed, primarily using the CLI at the moment, by passing in the particular model that you want to deploy. So you can see the list here. This includes some of the 5.4 models, 5.3.5, and then GPT-2 Medium and Mistral. They can already be run on Azure Foundry with a single CLI command. However, if you want to run a different model, you're not limited to those. You just have to do a little bit of work up front. So any ML flow model type can be run on an ACA with the serverless GPUs. You just have to follow a process to configure that based on a template that's provided from GitHub and set that up initially. It doesn't take very long. And then you can basically use any ML flow model. Now that we know how this all works, let's go and see it in action and see some use cases that are a great fit for serverless GPUs. So for our first demo, we're going to be creating a holiday card generator. This is a fast API application that's using stable diffusion to generate images. And the key thing here is that with GPUs, we're able to generate that image in about 10 to 15 seconds, whereas if we're running that on a CPU, we're talking multiple minutes. So this allows us to speed up our image generation significantly. And this demo is more of your classical HTTP scaling based container that's going to be running whilst there are app requests coming in, but scaled down to 0 once they're. So we've built this container, it's in a container registry, and we're now going to get that deployed into Container Apps. So we're going to use the portal for this demo to get things deployed, but obviously everything you're doing here, you could use CLI or infrastructure as code to create. The first thing we're going to do is we're going to go through the process of creating a container app. We're going to determine where this needs to live. And then the first thing we need to do is set up a container app environment. I'm going to create a new environment here for the purposes of this demo. So we need to set up an environment name. And then the important thing we need to look at is the workload profiles. And in particular, add a workload profile. And you can see in here, we've got standard workload profiles for the D series and E series, which is the dedicated VMs that you'll be paying whilst those VMs are deployed. We've then also got a new consumption GPU workload profile. You've got two options here. You've got the A100 and the T4, as we mentioned. Which one you need, and deploy that workload profile into our environment. After that, we're now going to go through the process to actually set up our application in that environment. So we're going to define the image and registry we want that image to come from. Most of the other information here is fairly default. But the important bit is when we get to the resource allocation section, where we are going to configure the workload profile to use. So you can see we picked the profile as consumption, and then we've ticked the GPU box and picked our GPU profile for our application to use. Now go ahead and create that, and what we should see is our environment gets created and then our application gets deployed into that environment. If we have a look at our application, you can see this is now running, and if we go to that URL for the application, you can see our Christmas card generator is up and running and able to generate us some images. If we look at the instances of our application, we can see we've got one running currently. And if we look at the configuration, it's using the HTTP scaler. And once we stop using that after a brief amount of time, it's going to scale that down to 0, so we're not being charged for those resources. Our second scenario we're going to have a look at is more of a batch type job. So continuing the festive theme, we've got a Santa's letter processor. The idea here is there are a number of handwritten letters that have been sent to Santa, and we want to be able to process those as a batch and determine the content of the letter, and also do some sentiment analysis on it to determine what the sentiment of the letter was. And so this is an ideal task for ACA jobs. This is not something we need running all the time. It's a job that we want to schedule based on a particular scenario. And you could have those jobs running on a timer, but in our case, we're going to use CADA, and it's going to scale our workload or our job based on the number of items in a storage queue. So if we have a look at the environment, we've already got our job deployed. And If we have a look at our scaling information, you can see we've got it configured to use CADA to scale based on that storage queue. So let's then see it in action. We're going to go over to our CLI, and we've got a Python script that we're using to actually create these handwritten letters as JPEGs. If we run that, what we should see is we got some JPEGs created. And if we have a look at one of those, we've got a nice layer to center there. So now we're ready to go. What we're going to do is run another script, which is going to upload those images to blob storage, and then add an item to the storage queue for each of them to be processed. And if we hop on over now to the storage queue and have a look at that, you can see we've got those 5 items in there ready for processing. And if we go and have a look at our actual container app now and have a look at the current executions, we should see that the job is now running and processing those. That takes a little while to run, so we'll leave that run and come back to it in a second. So the job's now finished. And if we have a quick look at the job logs, we can see that it's processed those images. And if we now go and have a quick look in our storage account and have a look at the blobs, you can see we've created blobs for each of those items. And if we have a look at the content, and you can see there that we've been able to use OCR, so discover the text. We've got the full text listing down here, and then we've also got a sentiment analysis done on that OCR. All of that done within our model that's been running on ACA. But there are a few best practices and tips you can take to make sure that you're getting the best performance versus cost out of your application when running with serverless GPUs. The first thing is dealing with cold start. As we already discussed, we want to scale those containers down to 0 wherever possible to save us costs when they're not in use. And what that does mean is that the first time a user hits your application or you trigger a job, it's going to take a little bit of time to spin up that first container. And so there are a few strategies you can look at to see how you can improve that. First up, you can always keep the minimum replicas down to 1. That obviously will avoid any cold start, but you will get then extra charges for that container that's running at all times. You can look at the size of your container image and see what you can do to optimize it and make it as small as possible so that when the container starts up, it runs quickly. You're also going to want to amend any applications that are calling your serverless GPU applications to be able to deal with any sort of delay in cold start and to retry any requests. Next, when we're looking at your GPU selection, as we saw before, there are 2 different types of GPUs. You need to make sure you pick the right GPU for the right job. The A100 is the more expensive option that's great for heavy training, large models, complex processing. The T4 is the smaller model. It's cheaper, it's great for inferencing, smaller models, cost-optimized workloads. Next thing to think about is the actual access to the GPU. So bear in mind that each application you're running within, or at least each, next thing to think about is the actual access to the GPU. So each replica only has 1 GPU. So if you run multiple containers within your replica, like sidecars and so on, only one of those is going to be able to access the GPU. You can't share that GPU across multiple containers. Next thing is you want to be actively involved in cost management. You want to make sure that you are getting charged to what you thought you were and you haven't got containers that are racking up a bill. It's quite easy to rack up quite a big bill with some of these, particularly the A100 GPUs. So you want to make sure that your containers are in fact scaling down to 0, that they are in fact being triggered by the CADA plans you had in place and only scaling up to the size you think they are and not going much larger. Keep an eye on your costs and make sure your workload is fitting within your expectations. It's also important to think about region selection. Only some regions support serverless GPUs, so you'll want to make sure that you pick the appropriate region. And if you're going to go multi-region, for example, then make sure both your regions that you want to support can deal with serverless GPUs. And then finally, you want to think about IP allocation. If you are attaching your container app environment to a virtual network, then each replica of your container app is going to use an IP, and so you need to make sure that your address space is able to deal with that. Okay, and that's all we really have to talk about today. Hopefully you've seen that the serverless GPU model in container apps provides you with a really great and cost-effective and dynamic way to use GPUs with machine learning and AI models to get really powerful container-based workloads running, but doing that in an on-demand way and paying per second for your actual usage. I hope you enjoyed that session, and I hope you have a great Christmas.